This is a video for the Climate Emergency Institute on the climate emergency, and on the August 2021 IPCC Arctic 6th Assessment Working Group 1 report, which was released with much media coverage. The Working Group 1 is the science, and this presentation is on the summary for policymakers called the SPM. The SPM is the only part of the assessment which is acknowledged by the world's governments, and it is acknowledged by all the world's governments, and the only one which is covered by the media. This particular report is the most important report on anything ever. For the sake of your future and your family, I'd ask you, please get to know this report, and this is what I've been trying to do. This is what I've been trying to do for many years now. I'm Peter Carter. I'm making the video on the 17th of August. In 2021, with this report, the only question is this: how do we love all the children in all of the world? And we have to ask ourselves that question because it is not looking good for the world's children. So there was a considerable media coverage of this report, and that was good. It showed that we are right out of time to avoid a catastrophe for the human race and planet Earth with respect to the climate and biodiversity. We're all aware that in 2021 the world got a taste of the future, with many worldwide unprecedented extreme weather events. The future from here on is going to get much worse faster. So we saw this year again heat waves, wildfires, droughts, superstorms, and floods. And all this is due to the industrial age carbon dioxide and other greenhouse gas emissions. Now, as a result of that, we are in a new age of a worse and worsening world. This is a short statement from the news release, and it really is all we have to know about the 6th Assessment Working Group 1, because this is the essential message. Under a headline, Faster Warming, it says the report finds unless there are immediate, rapid and large-scale reductions in greenhouse gas emissions, limiting warming to close to 1.5 degrees C or even 2 degrees C will be beyond reach. So I stress that word immediate. Immediate decline of emissions by 2020, sustained at the latest, has been in the IPCC assessments and reports for many years. And I point out here that this 2 degrees C now, for a number of years, has only been to 2100. Warming will continue, albeit slower, and it will continue to slowly increase for hundreds of years after 2100. So we're looking here, I'm certainly focusing on the 1.5 degrees C danger limit and 2 degrees C, and this 2 degrees C by 2100. The 2018 IPCC 1.5 degrees C report showed very clearly that 1.5 degrees C is globally disastrous and 2 degrees C is global catastrophe. This applies to all world regions and all populations. This is made very clear in this Working Group 1 report. Neither of these worlds, 1.5 or 2 degrees C, are worlds anyone would want to live in. They both require, as I'm trying to stress, immediate, rapid global emissions decline of carbon dioxide and methane. And methane has been brought into unusual prominence in this report, and emissions of methane have to be put into sharp decline, because doing this to carbon dioxide alone is not going to be enough to limit to 2 degrees C. 1.5 degrees C as it is, because we are way, way late, because emissions decline has been delayed and delayed and delayed, and it's still not happening. 1.5 degrees C would require carbon dioxide removal, which is unfeasible in the foreseeable future. 2 degrees C, as I mentioned, by 2100, which is what the scientists are looking at these days, is 3 degrees C by 2300, and of course requires much more carbon dioxide removal. I'm just going to stray a little bit from the Working Group 1 report to show you the latest report of August 2021 from Climate Action Tracker. This is a website and project run by climate experts, and I'm showing it to you because of the current policies. Current policies by Climate Action Tracker are projected to lead to a catastrophic global temperature increase of 2.9 degrees C, almost 3 degrees C, by 2100, and that'll be much higher for many hundreds of years after 2100. Today, we're at 1.2 degrees C of warming. So, our governments and fossil fuel corporations and investment banks that finance the fossil fuel corporations, they have world emissions headed for exactly the opposite direction to what the IPCC has been calling for years and years. They're going up, and the International Energy Agency, the IEA, recently reported that the post-COVID economic recovery has focused so much and given so much of the funding, the credit funding, to the fossil fuel industries that incredibly coal has already surpassed its 2019 peak. Coal has already surpassed its 2019 pre-COVID peak, and oil is almost at that peak, and it's probably right now, even today, at that peak. Fossil fuels, in other words, have already been pushed up so rapidly that they're back in the emissions, huge amount of emissions, before the COVID pause. This is the other graph that I've simplified from that Climate Action Tracker report. This is from May of 2021, still this year. It shows global CO2 equivalents, that's CO2, also methane and nitrous oxide, so it's entirely appropriate to what we have to do. And this shows the current policies going to 3 degrees C by 2100. And very importantly here, Climate Action Tracker shows what has been shown by countless reports and assessments, that for 1.5 degrees C, emissions have to decline from 2020 rapidly, and also for 2 degrees C, global emissions have to decline from 2020. This IPCC assessment, this is the last chance for the human race. Planet Earth has been changed by carbon dioxide and our greenhouse gas emissions, and it's been changed for hundreds and thousands of years into the future. At best, the world will be a harsh, globally disastrous planet to inhabit. Multiple, frequent, and even compound, as reported in this Working Group 1 report, multiple of these hard-hitting extreme events will be the nature of the new climate. The world will be at 1.5 degrees C, according to this Working Group 1 report, by the early 2030s, 10 years earlier than estimated last time by the IPCC, and of course this global temperature will still be on an increasing trend, and it will reach 2 degrees C by 2045, and that was in the IPCC 2018 1.5 degrees C models. So climate catastrophe, and catastrophe for the entire world, is just around the corner. It will be very, very much worse than the IPCC report, this Working Group 1 report, if we don't force our governments to slash emissions right away. Governments have been told this for years and years and years by the IPCC. But it will be worse in any case, because the so-called conservative and underestimating IPCC, again, this year, they excluded the inevitable single worst effect of global warming, and that is amplifying feedbacks, and also the effect of carbon sinks failing. Now, the Working Group 1 report here for the first time said that carbon sinks are going to fail, and they're going to fail this century. But they shied away from the amplifying feedbacks. It's probably okay to not go into the amplifying feedbacks up to 1.5 to 2 degrees C, but at 2 degrees C certainly. Amplifying feedbacks, which are from very, very large sources, will have gained momentum enough that they would have started to further boost the global surface temperature increase, which is already accelerating. So these feedbacks will increase with warming, and they will add to the accelerated global warming of today. These must be minimized for our future survival. So therefore, to avoid the absolute catastrophic effect of these many large source amplifying feedbacks, global emissions must be put into decline immediately. This is from the IPCC press release, and a lot of what I'm going to be doing in this video is trying to help you to go to the IPCC Working Group report and to help you navigate and obtain the information and check on the information that everybody needs for themselves and their family. So the press release was climate change, this was the headline, climate change, widespread, rapid, and intensifying. Scientists are observing changes in the Earth's climate in every region and across the whole climate system, which means all systems of the biosphere. Many of the changes observed in the climate are unprecedented in thousands, if not hundreds of thousands of years. And some of the changes already set in motion, such as continued sea level rise, are irreversible over hundreds to thousands of years. However, strong and sustained reductions in emissions of carbon dioxide, which must be immediate, and other greenhouse gases would limit climate change. While benefits for air quality would come quickly, it could take 20 to 30 years to see the global temperatures stabilize. That is if we put emissions into decline right away, meaning we have to force governments to put emissions into decline right away. So here is the faster warming headline section. The report provides new estimates of the chances of crossing the global warming level of 1.5 degrees C in the next few decades, and finds, as I've already said, unless there are immediate, rapid, and large-scale reductions in greenhouse gas emissions, limiting warming to close to 1.5 degrees C or even 2 degrees C will be beyond reach. Therefore, because our governments are today increasing global greenhouse gas emissions and not putting them into decrease, we will not limit to 1.5 degrees C and will not limit to 2 degrees C. And that means a catastrophic planet Earth. The report shows that emissions of greenhouse gases from human activities are responsible for approximately 1.1 degrees C of warming, that's to 2019, since pre-industrial 1850 to 1900, and finds that over the next 20 years, global temperature is expected to reach or exceed 1.5 degrees C of warming. We are not going to be able to limit to 1.5 degrees C of warming. We will face very soon a disastrous planet Earth climbing temperatures above 1.5 degrees C. So that's the very, very useful one-page press release. And this here are the headline statements. And the IPCC, very usefully for the first time in its last full assessment of 2014, gave like a two-pager headline statements. The headline statements for this working group 1 is basically a one-pager. Current state of the climate. It is unequivocal that human influence has warmed the atmosphere, ocean, and heat. It's taken decades for the IPCC to say that, for the models to catch up, and now finally they're able to say it's unequivocal. Widespread and rapid changes in the atmosphere, ocean, and cryosphere, that's the snow and ice covered parts of the planet, and the biosphere have occurred. The scale of recent changes across the climate system as a whole and the present state of many aspects of the climate system are unprecedented over many centuries to many thousands of years. Human-induced climate change is already affecting many weather and climate extremes in every region across the globe. Extreme weather events are a single category of impacts by the IPCC, and as such they are the single most damaging category of impacts to populations and to crops. Next is possible climate futures. Global surface temperature will continue to increase at least till the mid-century under all emissions scenarios considered. So we face a global temperature increase up to 2050. That's because of the momentum, the inertia that is in the climate system. Many changes in the climate system become larger in direct relation to increased global warming. They include increases in the frequency of intensity of hot extremes, marine heat waves, heavy precipitation, droughts in regions, and intense tropical cyclones, as well as reductions in Arctic sea ice, snow cover, and permafrost. Under scenarios with increasing CO2 emissions, which is all scenarios that our governments have us looking at, the ocean and land carbon sinks, and this is the first time the IPCC has ever acknowledged this, the ocean and land carbon sinks are projected to be less effective at slowing the accumulation of CO2 in the atmosphere. Most of you are probably been aware for some time, that under continued increasing atmospheric CO2, a lot of that CO2 has been removed and buffered the full effect on the global temperature, removed by so-called land and ocean carbon sinks. They would have been better called storages, land and ocean carbon storages, because they will not last forever, and although they have reduced by about 50% the atmospheric CO2 which would have otherwise occurred, as the IPCC most importantly says here, that is not going to continue, and in particular the land carbon sink will start declining, and even the ocean carbon sink will be declining sometime this century. That is terrible, terrible news. Many changes due to past and future greenhouse gas emissions are irreversible for centuries to millennia, especially changes in the ocean, ice sheets, and global sea level. With further global warming, every region is projected to increasingly experience concurrent and multiple changes. That means adverse impacts. Low likelihood outcomes, low likelihood by computer projections that is, such as compound extreme events and warming substantially larger than the assessed, cannot be ruled out. So the next section, which is very, very useful for you, and is the frequently asked questions, and all the IPCC reports have frequently asked questions, and they're all really great because they hit on the main important parts of the reports, and they put it in readily comprehensible non-science expert language. So here's one example. First question: how is global warming different than before? It's warming almost everywhere. It's warming rapidly. The warming reversed the long-term cooling. It has been a long, long time since it's been this warm. So here's another frequently asked question, which is on future global emissions. I'm going to repeat, global emissions must, they had to, go into rapid decline on and from 2020. So sustained reduction in carbon dioxide emissions would become apparent in atmospheric concentration after 5 to 10 years. So you slash emissions, it takes a few years for that to show up in the atmospheric CO2 concentration, but it takes 20 to 30 years for that to show up in an improvement in the global warming, the global temperature increase. Now I want you to look at this. This decline of CO2 under the best case scenario is from 2020. And this is the worst case scenario in comparison. Well, actually, it's not the totally worst case. This is the next to worst case. And as you see, that does not decline in 2020. It keeps going up. So I just want to highlight this, that in the best case scenario, the emissions of CO2 declines 2020. It's able to continue declining fast because of assumed carbon dioxide removal. This image here shows that warming will be stronger in the Arctic, stronger on the land, and stronger in the northern hemisphere. This is a projection of global warming at 1.5 degrees C, and there you see that the Arctic is being heated up much faster than anywhere else. Subarctic faster than the rest of the planet, and the northern hemisphere faster than the southern hemisphere. There's Greenland there, Scandinavia, Sweden, Norway, Finland there. This is North Africa. So the strongest regions of warming are in North America, in the permafrost, in west central and eastern Canada there, and in the western United States. This is at 1.5 degrees C. In South America, it's in Argentina and the southern part of Brazil. It's in North Africa and also in South Africa. Higher warming is in Scandinavia, Norway, Sweden, Finland, and very high warming again over in subarctic Siberia, but more warming in the whole of Eastern Europe and the whole of Russia over here, and into northern China here. There's also higher warming in the West Antarctic Peninsula. So these regions here of Alaska and northern Canada and Siberia here, of course, are crucial because these regions contain the vast amount of permafrost. So this is a frequent question 5.2, and this is on permafrost. Can thawing permafrost substantially increase global warming? The Arctic is the biggest climate-sensitive carbon pool on Earth, storing twice as much carbon in its frozen soils, or permafrost, than is currently stored in the atmosphere. As the Arctic region warms faster than anywhere else on Earth, there are concerns that this warming could release greenhouse gases to the atmosphere and therefore significantly amplify climate change. Now, although it has it in the FAQs, This is one reason, actually, why it's very important and productive to go to the FAQs. Although the AR6 Working Group 1 report avoids the risk of permafrost thawing inevitably releasing more greenhouse gases, it does acknowledge it in the FAQ here. And there's even some good images. Now note that the permafrost is thawing and it's already emitting the three main greenhouse gases: methane, CO2 and nitrous oxide. So here's the carbon stored in the Arctic and subarctic regions, and obviously the darker orange and red is more carbon, and you can see though the absolute vast region that has the highest carbon in the soils on planet Earth. This is very useful and good too, because it shows permafrost that is vulnerable to abrupt thaw. The abrupt thaw effect of permafrost has already been recognized by the scientific research for the past few years, and widespread regions of this permafrost, as you could see, are vulnerable to an abrupt thaw, which will push up the feedback emissions even faster. And this I've just included here, which is from another chapter in this report, to show you Arctic temperature increase at 2 degrees C. And there you are seeing 5 and 6 degrees C there. Now, as I said, thawing permafrost will substantially increase global warming because the feedback emissions from permafrost, increase with both the global surface temperature increase, the global surface heating, and the duration and the time of that global heating, which is an on and on and on forever situation. So it's already emitting the three big greenhouse gases. The Arctic has switched from a carbon sink to source. That's the NOAA. Their Arctic report card in 2016, confirmed in 2019. And the IPCC AR6 Working Group 1 here ignores the multiple and inter-reinforcing Arctic feedbacks. And that is very bad. There's been a continual tendency for the IPCC to cast a blind eye, which would be the best way to put it, I suppose, but really ignore the what is clearly, and we've always known, the single most catastrophically dangerous effect of global surface warming. So this brings us to the summary for policymakers, which is what this Working Group 1 report is all about with respect to being acknowledged by governments and on the media coverage. So it's called the SPM, and as I've said, it's the only one that's acknowledged by governments and gets reporting. The SPM tends to be conservative and underestimating, and there's a good, or well, rather bad reason for that. It originally was a good reason. All the IPCC scientists must agree on everything, and then all the IPCC policymakers that sit on the panel representing all the world governments, they must all agree, and they do so by a line-by-line scrutiny process. So in other words, the IPCC assessments with respect to a scientific assessment are unique, they're extraordinary, in so much as governments get to be involved right the way through the assessment process. This image here from the SPM shows that global surface temperature increase is accelerating, and as the Working Group 1 report acknowledged, it's going at a rate faster over the past decade than anticipated, and that's pretty obvious here. So this image from the Working Group 1 shows the past 2,000 years of global temperature increase, and this is obviously an abrupt global warming or an abrupt global surface heating. This is over the past 170 years, and mainly the IPCC has used this to show that the computer projections show this now massive difference between the projections without our greenhouse gas emissions and the projections and observations with our greenhouse gas emissions. This I've just taken from 2000 to 2020. The black, rather upper downish line is the observed or the recorded actual global warming, and the thin brownish one there is the simulated or model warming. Suffice to show that there is acceleration even quite recently on the global surface temperature increase. I've just gone back to the 2018 IPCC 1.5 degrees C report to show you that emissions had to have gone into decline on and from 2020 and to a rapid decline. This I've adapted to simplify it, and I think we are all aware that emissions have to drop by 50% by 2030, and then here by 2050 the CO2 emissions have dropped by 92%. This illustration from which is the original illustration, which I've adapted and simplified here. Here's the original one. Really what everybody's missed is the fact that in the 1.5 degrees C report, they for the first time, the IPCC put down in percentages the reduction of each fossil fuel that was necessary for a chance at 1.5 degrees C. And so you see coal, oil and gas. Now suffice to say that by 2050 fossil fuel production and fossil fuel emissions has to be reduced to virtually zero. So we've got all of this nonsense nowadays, which everybody has fallen for. The corporations, of course, they're very glad to have fallen for. At this point I have to introduce to you the IPCC AR6 scenarios. The IPCC changes their scenarios about with every other assessment, which is mighty confusing. These are new scenarios. They're called the SSPs. I'm showing you the scenario projections, and that's why I have to show you the scenarios, because we're going to be looking at projections for the future. And here we have carbon dioxide, and here we have methane. CO2, carbon dioxide, CH4, methane. And there are several scenarios here. The only ones that we need to know are the worst case scenarios and the best case scenarios. The worst case scenario, which is now called SSP 5.85, is the scenario that the world economy is currently tracking. There are two best case scenarios, one called SSP 2.6 and the other one called SSP 1.9, and obviously the lowest emissions one is the one for 1.5 degrees C, and the higher one for around 2 degrees C, but by 2100. So I've pointed out where these scenarios have the world put global emissions into decline in order to have a chance of the 2 degrees C limit by 2100, or previously a chance at 1.5 degrees C, but that chance has been thrown away by our governments already. So the scenarios had the global emissions of carbon dioxide declining from 2020. So we are already beyond the time when emissions should have been put into rapid and sustained decline, but instead our governments are currently this year pushing emissions up faster, almost faster than they ever have. This is rate of increase, according to the IEA, is the second fastest in the history of their records. So now we go on to methane, and the models had methane going into a decline from 2015. So clearly we are way beyond a survivable mitigation response both for CO2 and for methane. And although methane hasn't been featured in the previous IPCC assessments very much, in this working group 1 it is, because the IPCC now recognize that methane has to be put into immediate and rapid decline, as well as CO2. So you'll see from these projections that the frequent reference in Working Group 1 report to immediate emissions decline is more than true. Here is a hugely important statement from the Working Group 1. With every increment of global warming, changes get larger in regional mean temperature, precipitation, and soil moisture. So these images, they're projections at 1.5 degrees C warming and at 2 degrees C warming, and you can see the regional, much larger increase over the land, particularly the land of the northern hemisphere, most particularly in the Arctic, and a big difference between the temperature increases in these regions at 2 degrees C compared to 1.5 degrees C. This shows a world drought. This is model projected soil moisture, and it gets drier, the browner, and it gets wetter, the greener. Here is 1.5 degrees C, here is 2 degrees C, and you can see very readily that there are large, very important regions which get dried out, which have progressively decreasing amounts of soil moisture, which is drought. This affects the most important food producing regions in the northern hemisphere, and this is the most recent image. It's a satellite image actually of the food production on the planet, the green indicating crop intensity. So you can see Canada, USA, South America. I've also added the Amazon here because the Amazon is already drying out, and it's going to dry out way worse at 1.5 and 2 degrees C. It is really all over for the Amazon, and that is a massive carbon feedback, and the Amazon is already switched from, like the Arctic, the Amazon already switched from a carbon sink to a carbon source. Europe, you see, going into negative soil moisture, very much South Africa, huge region here, also North Africa and these other regions, but also China, showing drought, dryness of the soil at 1.5 degrees C and more at 2 degrees C. So with respect to world drought, we are in a really catastrophic situation that we're looking at. With respect to world food security, and we're looking, because we can't avoid 1.5 degrees C, we're definitely looking at a reduction in world food productivity, and because of 2 degrees C, a severe reduction. Our crop yields are doing very well. They're still increasing, and the stocks of cereals are still large. But when we get towards 1.5 degrees C, things are going to change very much for the worse. Heat waves, of course, increase, and this was reported in the 2014 fifth assessment, that as global temperatures increase, extreme heat events, heat waves, they increase in frequency, intensity, and duration. This is very harmful to human populations and to crops. This is somewhat of a complicated looking diagram for the Working Group 1, but it's actually very good and very important. it shows hot extremes, heat waves over land. And it does this by projecting the increase in 10-year events, a heat wave situation extreme which would normally happen once in 10 years, and then one which would normally happen once in 50 years. Here you see the increase in the frequency of these heat extremes and also the intensity. This on the left is the frequency and intensity increasing of a 10-year event, and here the increase of a 50-year event. The dots here illustrate very nicely the increase. Pre-industrial put at a metric of 1 for a 10-year extreme heat event, and then presently we're at almost 3 times that pre-industrial normal situation. At 1.5 degrees C, it will be 4 times, a 4-fold increase, and then at 2 degrees C, a 5.5 times increase. That's the frequency. At the same time, the intensity has gone up, goes up more at the 2 degrees C global warming. The 50-year event is actually even more dramatic. Once for pre-industrial becomes an increase of nearly 5 times for the 1 in 50 event, 8.5 times at 1.5 degrees C, and 14 times at 2 degrees C. So we are going to get a lot more 10-year event extreme heats in frequency and severity, but a great deal more of the 50-year events, and also a huge increase in the intensity of those normally 50-year events. So this says, and it's all modeled, it's all projected, and it is now detailed and definite, that the heat wave situation, which we already have had some nasty tastes of, particularly this year 2021, is going to get absolutely terrible. This is a similar illustration that Working Group 1 has done for drought, and this is a 10-year event. So the normal situation we put at 1 at pre-industrial. It's already almost doubled, 1.7 times the frequency of the drought, and at 1.5 degrees C it's doubled. So at 1.5 degrees C we're going to have drought at double the normal situation. At 2 degrees C it'll increase 2.5 times, and at the same time, of course, the intensity of the drought will also increase. So we've got increased frequency and intensity of heat waves and of drought. I'm now moving out of the SPM, and this is a brand new and very useful resource based, of course, on the modeling. And for the first time, this is Working Group 1 has an interactive atlas, and it actually took me some time to access and understand how to use this atlas. But you go to it on the site and then hit on the atlas, and you'll get to the section where the atlas is, and then you have to scroll down and you just hit regions, and then you'll find this sort of thing. There's a lot more data than what I'm going to show you here, but I'm going to show you the most important. I'm showing the projections under the worst case scenario because the world economy has the world tracking the worst case scenario, and our governments have told us that they have no intention of taking us off this worst case scenario. They're going to continue pushing and increasing fossil fuel extraction and combustion. So this is summertime, mean temperature change, and around 2030. The one thing that we've always needed the most, we've never had available, and it's rather obvious, that is the highest temperatures that will occur in the summertime, because they're most damaging to human populations, to crops, and to ecosystems. So here we have the mean temperature at 2030. It's from the pre-industrial, the 1850 to 1900 period, and then there's the scale that goes up to 4 and more than 6 degrees. And so here, with the interactive atlas, you can see the regional degrees of heating. It doesn't show the Arctic. It shows a bit of the Antarctic here, which gets, as you see, pretty darn hot. We're at 2021 now. So 2030, because of climate system inertia, is unavoidable. This is summertime temperature at 2050. So look at the huge, huge difference compared to 2030. And 2050, because of government's planet-destructing policies, we're not going to avoid this, apparently. Now it gets really, really interesting. This is the summertime maximum temperature change. So this gets really interesting and most important, because here we have summertime maximum temperature increase, and again at 2030, and you can see the regional situation here, and then you see a huge difference in the maximum temperature change, the maximum heating at 2050 compared to 2030. The last two here are the most important that I was able to obtain from the interactive atlas. This is the number of days in the summertime with a maximum temperature which is above 35 degrees. Now, why this is crucially important is that the IPCC has been reporting for many years that crop yields have a high temperature tolerance. In actual fact, over the tolerance, the crops plummet. And the quote here, which is from the fourth assessment in 2007, and also from the fifth assessment in 2014, this is actually from the fifth assessment, says crop yields have a large negative sensitivity to daytime temperatures around 30 degrees C throughout the growing season. High confidence. So the danger limit, in other words, is 30 degrees C, so 35 degrees C is way above the danger limit. And so this is why I put that image of world crop, the crop intensity, and then you can compare those regions that produce most of our food with the regions that are affected with maximum heat, which is beyond the tolerance of the crops. And this then is for 2030, unavoidable, and this is for 2050, that our governments are making unavoidable. Now, I've also, of course, included the Amazon. As I've already said, we have lost the Amazon, or the Amazon has been lost to us and to our children and the future. And the loss of the Amazon, the dieback of the Amazon, will be a huge carbon feedback and increase in CO2, and so a further increase in the already accelerating global warming, global surface temperature increase. I've taken just a few images for the end here from Chapter 11, which is in this Working Group 1 report, which is the weather and climate extreme events in a changing climate. Here is a image that I've simplified. This is the land area affected by temperature extremes, and this has been recorded, and it's on to the 2010 decade. So you can see the land area affected by temperature extremes. The amount of land affected is accelerating rapidly. Here I get to the image which I've adapted for simplicity, in which the Working Group 1 report says that carbon sinks will decline. So they say the proportion of CO2 emissions taken up by land and ocean carbon sinks is smaller in scenarios with higher cumulative CO2 emissions. So the more we continue to emit CO2, we're being compelled to do that by our governments, by fossil fuel corporations and investment banks that finance these corporations with huge new extraction projects of fossil fuels, oil, gas, and we still have coal going up. Hundreds of coal mines are ongoing, being constructed and in the planning process. So we are on a situation, on a course in which the carbon sinks will start failing. They will take less and less and less of that carbon up. As a result, more and more and more CO2 will be left in the atmosphere, in addition to the CO2 that our fossil fuel industries are putting up there, and therefore there will be a further increase in the already accelerating global surface temperature increase. So there's the text that goes along with the very important acknowledgement that the carbon sinks, of course, cannot last forever, and we're looking at them failing over particularly the land carbon sinks over the forthcoming decades, and that's already started with the Amazon having been tipped from a carbon sink to a carbon source. Human activities affect all the major climate system components, with some responding over decades and others over centuries. So this shows the global surface temperature increase relative to pre-industrial. I've simplified it to show the worst case that we're on, and the best case, and we can only get on the best case if this year, and this is doable, if this year the governments reverse what they're doing and put global emissions back into decline. There I've just enlarged it to show that on the current scenario, on our current policies, we're going to be at 1.5 degrees C by 2028, and even on the best case scenario we'll be at 1.5 degrees C 2033. This just shows all the other SSP scenarios, but really the only one that we need to know is the worst case and the best case. This is Arctic sea ice. Summer Arctic starts to be almost ice-free by 2050, which is the same as the AR5 of 2014 said. This Working Group 1 science report, however, is different from previous assessments because the impacts and the projections are definite. They're not sort of maybe, perhaps. Now the models have got to the state in which the impacts and the temperature increases are definite. So, but if we look at the computer ranges, the summer Arctic could be start to be ice-free by 2030, because this is in the red range here. This is ocean acidification, And acidification is expressed as pH, and it's the inverse of pH. So this is the original image. I reversed it here so you can see the relative acidification. And this is the acceleration of ocean acidification on the current worst case scenario. And even on the best case scenario, ocean acidification will continue to increase till mid-century, and only then does it plateau and level off. This is global sea level change relative to 1900, and want to point out the fact here that we are on this worst case scenario, but as could very well happen and probably will happen, ice sheet instability will result in a huge further acceleration of sea level rise. Sea level rise is accelerating. So this dotted line here in actual fact shows what we can expect to happen, certainly unless we put emissions into decline on an immediate basis. This shows observed changes in temperature, and the global mean temperature is accelerating. This is the recorded temperatures up to 2020. The annual hottest temperature, this is the purple one, this is accelerating, and the land mean temperature is also accelerating. Here's the annual mean temperature response at 2 degrees C. That is a very, very dramatic, terrifying image of the 2 degree C world, which we are being headed to by our own governments. And this shows projected changes in the annual maximum temperature. And 1.5 degrees C here and at 2 degrees C here. So this shows extreme heat, in other words, the maximum temperature at the height of summer. And look at the crucial regions that are being affected maximally by the maximum temperature, and much, much worse, more widespread and more intense at 2 degrees C of warming. So this shows the frequency of extreme temperature events at present 1 degree C, 1.2 degrees C, increasing 1.5, 2, and 3. And there is an accelerating rate of increase here. That's the 50-year event, and there's the 10-year event. So extreme temperatures over global land. This is summertime frequency of 1 in 10-year soil moisture deficit drought. And so again, widespread regions of drought, regions that are food producing regions, and crucially the best food producing regions. So I'm just finishing with that image of Arctic temperature increase at 2 degrees C. The Arctic is now increasing at 3 times the global average. Used to be 2 times, now it's 3 times, and that's according to the NOAA and the AMAP, the Arctic Monitoring Assessment Program, their last publication. Here's then a final reminder of the one thing that we really, really have to know, and really, really have to act on, and act on it now. And this report finds unless there are immediate, rapid and large-scale reductions in greenhouse gas emissions, limiting warming to close to 1.5 degrees C, or even 2 degrees C will be out of reach. So my friends, so people out there, you know what you have to do. You have to dedicate your life at this time for some time to force your governments to stop increasing fossil fuel greenhouse gas emissions, and to put those greenhouse gas emissions into immediate decline that they can readily and easily do.